Financial Modeling, Topic 10, Fixed Income Portfolio Management, Section 4. We're going to create hedges for a levered bank portfolio. So we're going to have a model of a bank, and that bank is going to have assets of $10 million, which are a combination of some auto loan, home equity line of credits, HELOCs, should be a C there, and mortgages. Those quantities of those instruments, frequency of payment, coupons, yield to maturities, their par amounts, here are their prices. Now notice I'm not using modified duration and convexity here. I'm having to go to, say, to Bloomberg or another software and calculate the duration of a mortgage of, say, 3.5 years with a duration of the convexity of -200. I have my home equity line of credit, 1 year, and a convexity of -30 units. And I have my auto loan, has a duration of 3 with a convexity of -5. So these are my assets. They have a weighted average duration of 3.3 years and convexity of -172 and generate $894,000 of income. So we're going to replicate this portfolio, and then we're going to decide this bank, if it wants to finance $10 million of assets, it's going to set an equity value of $1 million. So we're going to raise $1 million of equity. They're then going to borrow $9 million by issuing 1, 10, and 30-year bonds. And that liability plus equity of $10 million is going to finance the purchase of these $10 million of assets. We're going to then calculate the duration and convexity of those liabilities. And then we're going to get our net position, our equity of $1 million. We're going to calculate the duration and convexity of our $1 million, determine what kind of income we can generate. And then we're going to see the risk of that portfolio, and then we're going to optimize these quantities. Now I'm going to start off with simply buying 30 each of 1s, 10s, and 30-year bonds. That'll give me my $9 million. But then I'll then try to find optimal quantities to reduce our interest rate risk. So let's go to our spreadsheet. And you'll notice I've already done one step for you, and that I've calculated the value of the total value of the bonds, or the mortgages and other loans. I calculated I have their durations in there as values. I've calculated the income, which is simply the quantity of bonds times the coupon times the par. That's the annual income of my auto loans, my home equity line of credit, and my mortgages. I've calculated the weighted average duration of assets, weighted average convexity, and total market value of my loans, and those loans generate income of $894,000. Now I'll do the same thing for my liabilities. I'm going to just copy and paste. Notice now for these are just straight coupon bonds, and I'm going to set this equal to -30 since I'm issuing them, -30 and -30. So my first solution is just going to be 30% of each of the bonds. That'll give me $9 million of financing. If I add my liability of -9 million in asset, that gives me $1 million of equity. So again, I'm going to issue, whoops, gotta add those. I'm going to issue $1 million in stock, borrow $9 million by issuing these 90 bonds. That'll give me $10 million to buy these assets. That gives me a leverage of 10 to 1, my assets over equity. However, if you look at the weighted average duration and convexity of the instruments, I have a big gap between the duration of assets and liabilities. I have a gap of 2.94 years in duration and a gap of 261 units of convexity. So that's a common thing to calculate, a duration gap and convexity gap. And it's an indicator of whether or not you've closed the durations and convexities of assets and liabilities. However, I'm going to calculate the duration and convexity of my $1 million. My net position is $1 million, right? I'm long 10 million, I'm short 9 million. So that $1 million of equity, let's calculate the duration and convexity of that equity position. The easiest thing to do is first calculate the income. That's the good part. I'm going to pay $645,000 a year in these 90 bonds, but I'm going to receive $894. So I'm going to get $249,000 of income. By the way, it's a nice fat ROEs, right? You got $249,000 of income and $1 million of equity. That gives me ROEs of 25%. So this looks like a pretty good banking model, even though it's levered 10 to 1. Now let me calculate the duration and convexity of this $1 million net position. I'm just going to take the duration of assets times the market value of assets, anchor that, market value of assets, plus the duration of liabilities times the market value of liabilities, anchor the market value of liabilities, divided by the total equity. So it's simply a weighted average. You're weighting the 331 by 10 million, you're weighting the 6 million by negative 9 million, and divide by the total. So this portfolio, this $1 million, has duration of negative 23 units. Oh, I got to anchor that 1 million right there. And has convexity of negative 2,500 units. What this means, when you have negative duration actually means that there's a positive relationship between prices and yields. When you have normal positive duration, right? If you see 3.31 is the duration of these bonds, or 6.24 years is the duration of these bonds, that means there's an inverse relationship between price and yield. When you actually see a negative duration, what that means is a positive relationship between price and yield. So it's going to be an upward sloping function of this $1 million interest rate exposure, or market value yield relationship, and it's going to droop downward. It's going to be a concave or negatively convex function. So here's my portfolio today. Let's try to see how risky this portfolio is. Let's see what happens to the portfolio value when rates are down 400 basis points and up 400 basis points, changing by 100 basis points. So I'm going to say equals open minus the duration, anchor it, times change in yield minus 400 basis points, plus 1/2 times convexity, anchor it, times change in yield squared, all times the market value of $1 million. So what this is minus duration times change in yield plus 1/2 change in yield squared times convexity times the initial market value. Looks like that would be the change in value, and then I'm going to add the initial $1 million back. So this is no longer change in value because that part is the change in value. I'm going to add back the initial value. So this is my new equity value. I am bankrupt if rates are down 400 basis points. I am bankrupt if rates are up 400 basis points. Looks like I'm bankrupt if rates are down 200 or up 400 basis points. So here's my exposure. Here's my $1 million of equity. Here's my exposure. We'll go back to PowerPoint and look at this. Here's my exposure. I now have a positive relationship between value and yield. That's giving me this negative duration of 23 years and negative convexity, which is drooping down. So here's a picture of negative duration and negative convexity, and I'm going bankrupt at 2 and 4%, down 2 or up 4. Now I can try to see if I can get a better portfolio. What if I can get a better mix of these bonds I'm issuing that have 0 duration? So what I'm going to do is run a different solver and just target the duration of equity to be equal to 0. I'm going to make sure the quantities are equal to or less than 0, since I'm issuing these bonds, I'm not buying them. And I want to keep $1 million equity value. So I'm going to go back to my spreadsheet, data, solver. I'm going to reset all. I simply want to set duration of equity to a value of 0 by changing my quantities of bonds. I want to add a constraint that I can either have the quantity of the value of the bonds be negative 9 million, or I can just set equity equal to 1 million. I'll just set equity equal to 1 million. and then add a constraint that all three of these weights are less than or equal to 0. And to do that, I need to now uncheck this box that say they're greater than or equal to, or non-negative. So I'm actually constraining the weight of these quantities to be negative and not non-negative. So I'll solve. Solver found a solution, and then here's my new picture. I go bankrupt at -3 and plus 300 basis point change, but that's better than a 200 basis point change making me go bankrupt. Now this is a picture of 0 duration, right? At the current $1 million of equity and rates unchanged, that's a flat duration and negative convexity. And the last solution, what we can do is get the risk minimizing. What if we just take that same solution, go back there, under solver, and all I want to do is maximize convexity. So my equity convexity, I want to maximize. Right now it's negative 2,114 units. I want to maximize that and add a constraint that duration stays at 0. And this will be the risk minimizing solution, forgetting about yield curve risk. So I now have negative 1,900 units of convexity instead of negative 2,100 units of convexity. And what you'll notice is this curve is a little less droopy. And that would be the risk minimizing solution. So in this topic, we created hedges for a levered banking portfolio.